Hello and welcome to this session, Kubernetes Database as a Service, a match made in the clouds. My name is Dewan Ahmed, and I'm here not to sell Kubernetes because this is a conference that has Kubernetes in its title. So I assume that you already know the benefits and the goodness of Kubernetes. What I'm here to tell you is managing stateful workloads and databases on Kubernetes is hard. And I'm here to break down the why. I'll leave you hanging with just that. I'll also help you understand which would be the situation to choose Kubernetes to host your stateful workload and some steps to go about that. My name is Dewan Ahmed. I'm a senior developer advocate at Ivan. It's a company that manages your data infrastructure on behalf of you based on open source technologies so that you can focus on your critical applications. I'm from the beautiful New Brunswick, which is the east coast of Canada. I have been focusing on application and data infrastructure for the last 10 years. In my free time, I'm a pro bono career coach. That means I help students and new grads to start a career in tech. My LinkedIn and Twitter handles are at the bottom of the screen. I'll appreciate if you connect with me. Now, this is Tim Hawkin, one of the creator of Kubernetes. And what Tim is saying is storage by itself is a hard problem to solve. Sprinkling Kubernetes on top of hard problems don't make them any easier. Now, you can ask that, hey, Dewan, like if it's so hard, why are we doing it? One of the reasons is spreadsheets don't scale. And if we start putting JSONs and CSVs on an S3 bucket, we won't have ACID compliance. That means it's a hard problem, but there are ways to do it. And part of my talk will address that piece. So how do you solve a hard problem? Well, we break it down into smaller problems, and hopefully that helps us to solve that hard problem. So let's understand, how do we choose the right storage? Now, there are some factors to consider. And the first factor is accessibility, which is the granularity of your application and data, how close they are co-located. Does it need to be on the same rack, which is your application and your storage backend? Can they be on the same node or different clusters? Now, this is important because this will determine how flexible your application pods can be within the cluster when there are a lot of moving parts. The second factor in choosing the right storage is availability, which is the resiliency during a failure. Can your storage solution survive a node failure or a rack failure or a zone failure? Oftentimes, your accessibility and your availability might seem similar, but sometimes they are different. For example, for a single NFS server, accessibility is global, but availability is single server. The third point in choosing the right storage is access mode. That is, how are you accessing the data? How many nodes can access the volume concurrently? This is important because this will restrict how many replicas of your application you can run at a given time. Next, when choosing the right storage, you have to consider durability, which is the data replication factor. How many disks can fail before you completely lost your data? The other two factors are usual, which are the performance and cost factor when choosing the right storage. If we look at these different levels from our stateful applications to databases, block or file storage, all the way to the physical storage, we realize then that's where at the very bottom stage, which is the blue stage, the rubber hits the road or the bits hits the disk. But in today's talk, we are not addressing all these layers. We are focusing on the database piece. And the pieces of database on Kubernetes problem has three parts. The first part is the choice of database. The second part is the deployment option. And the third piece is managing database on Kubernetes. Now, in the Hoover app, I asked a question that how many of you are managing your stateful workload on Kubernetes? Feel free to answer there. And if you have any questions, I'll address that at the end of the talk. But if you have any questions, meanwhile, feel free to add it there to the queue. So let's talk about the first issue, which is the choice of database. There's a good news and a bad news. So this is the CNCF landscape, but not the entire landscape. This is the database subsection of the landscape. So the good news is we have a lot of options. And the bad news is also we have a lot of options. So options are good, but it also can create confusions on which one we should choose. So when choosing the right database, there are again some of the factors that we might consider. The first factor is the query pattern. So how are you fetching the data? Are you fetching by a single key all the time? If that is the case, you can use a key value store like Redis. Are you fetching by a key, but then some other values at some time? Then maybe you could consider a wide column DB. If it's a complex query using multiple values, then a relational database might be the right fit. The next factor is consistency. Do you really need strong consistency that you need to have a read right after you write data? If that is the case, relational database might be suitable. If eventual consistency is okay, then you might consider other types of database. Next, a lot of databases, they are, or most databases, they are limited by the amount of space on disk, and they hit performance issues as the number of nodes and shards grow. So this is something you have to factor in when choosing the right database for your applications. This often forgot point about maturity comes in handy when you're choosing the right database. It might be tempting to go with the latest and shiny project, but when you are running something in production, you probably need solid documentation. Does that project has the documentation? And if you need support, does it offer that support? So the trust and the documentation for those project or product might be really essential for your need. And then this is for managed solution. You have to consider about the cost. Are you okay with what's the cost that's presented to you? Is the cost transparent? For example, the company I work at, Ivan, it has a transparent model where you pay for the service and all the networking costs are included in the pricing model. So when you're running stateful workloads, or if you're running a managed database, you have to consider the resource cost, but also the dependent resources, for example, the networking costs that comes with the databases. So now that we talked about the choice of databases, let's talk about the deployment options. So you could have an unmanaged options where you're managing the database yourself, or you could have a managed option. Under the unmanaged option, you can have your database running within Kubernetes, or you can have it run outside of Kubernetes. For example, you can have a virtual machine where you're running your database. I saw one of the questions in the chat was exactly related to that, which we'll address at the end of this session. So one thing to keep in mind is the deployment and consumption of your database are totally independent problems. That means you can consume the database from your Kubernetes control plane, but the deployment of your database could be within Kubernetes, it could be outside of Kubernetes. Now, you can ask that, hey, Dewan, like, what's the difference? Whether it's my application pods, whether it's a pod for my stateful workloads, what's the difference? The difference is the containers for your applications, those are ephemeral. So those can come and go, and we're treating them like cattle and not pet. But as soon as we're hitting persistency, your data is not ephemeral. You want them to be lived and backed up. And that's where things get a bit tricky when you're managing database on Kubernetes. So let's see how we manage database on Kubernetes. So at first, you can roll your own. That means you can have an on-prem database, you can have a virtual machine, and then you have a database right there. So in this solution, you totally separate the data plane out of Kubernetes. You'd have to perform all the administrative tasks like deployment, backups, secret management, certificate management, all by yourself or your engineering team. You'll have separate metrics and logging from the Kubernetes control plane. The next is you are actually deploying your database within Kubernetes, let's say using stateful sets. Stateful set is the workload API object used to manage stateful applications. So this is a bit different than deployment. I'm not going into too much deep on these concepts, but stateful sets gives you that stickiness that your persistent workload needs. Now, stateful sets provides each pod two unique identifiers. One is the network identifier, and one is the storage identifier. And these help you remember that if a pod goes down, when it comes back up, it has the same host name so that your applications can still communicate. Now, the third option is using a managed service. Let's say a database as a service using a purpose-built Kubernetes operator. So you're controlling the data plane from your Kubernetes cluster, but the database is not within Kubernetes. It's running outside. If we compare this third solution with the second solution, where your database was deployed as a stateful set, that database is limited to the Kubernetes cluster resources. It shares the compute units with other pods in that Kubernetes cluster. So for example, if I give an Ivan for Kubernetes operator, which we'll see in the demo today, when you create a database, that database is not limited to the Kubernetes cluster resources. It can be created in different origin or different cloud provider. You can scale up your resources without being bound to the Kubernetes cluster resources. One other thing I'd like to mention is the database that is hosted on some vendor or some provider, those typically perform better because the in-house of know-how, where it's tuned differently, and a specialist team has managed and tuned it up for your needs. The service provider would manage all the maintenance tasks like backups, patching, scaling. As an operator or a system admin, you'd focus on your control plane, and you'd be using the operator to talk to the database. Now, this is a flowchart to understand when to run a database on Kubernetes or not. So I know the font is a bit small in this, so I'll exit the presentation mode, and hopefully now you're seeing it a bit clearly. So the first question is the database Kubernetes friendly? That means, does it include concepts like sharding, failover election, and replication built into its DNA? For example, Cassandra. So if the answer is no, then you can ask that, is there an operator to help you? If the answer is no again, you can see that what's the ops workload? That means what are the types of data that are being written? Do they have more transient and caching layers, which helps when running on Kubernetes? And if the answer is yes, you can run it on a virtual machine, which was our first solution. Now, the second path in this flowchart is if the database is Kubernetes friendly, and then if you ask if the ops workload is acceptable, that means you have an engineering team who's familiar with both the database and they're familiar with Kubernetes as well, and you have both resources, then you can run it on Kubernetes, which was your second solution, running as stateful set. But let's see the third option, where the ops workload might not be acceptable. So this is a solution where you don't have an expert team of DBAs who knows ins and outs of managing a highly scalable database. You want to focus on your applications and want to let someone else focus on rolling out, managing, patching, scaling, and securing the database. This solution is the third solution where you use some sort of managed service, something like Ivan, for example. So I'll go back to the presentation mode and give you a quick overview of this highly complex architecture. So the demo has three pieces where I have a Kubernetes cluster, and I'm installing Ivan operator on this cluster. Within this operator, I'm talking to Ivan platform to create a PostgreSQL resource. The actual physical storage is on the cloud provider. So there are 5 cloud providers for you to choose from. We'll be seeing which cloud provider and region we choose. But this is a very simplified diagram on what is happening in the demo. You could use any Kubernetes cluster. I'm using a local option, which is kind, and I'm creating a cluster. I'm calling it J4K Kubernetes cluster. Within a few seconds, we'll see that our cluster would be up and running. The control plane is being started right now. All right, so let's make sure that we can execute kubectl commands. So the kubectl cluster info, that looks right. We have our Kubernetes control plane running locally. So this is where we are installing a dependency operator. The dependency operator is called cert manager, and we're using cert manager operator to handle the certifications. The TLS certificates, to be precise. So now the pods for the cert manager operator are running. So now I'm adding the Helm repository for the Ivan chart. You can directly install using a kubectl command, but the Helm way is the recommended way. So with these two commands, I'm creating the CRDs and also installing the Ivan operator. So now that the operator is deployed, we'll see how we create an Ivan for PostgreSQL resource. So we see the operator is installed successfully and it's running. So this is the Ivan console, and we need to create an authentication token. So this will work as an authentication from the Kubernetes cluster to talk to the Ivan platform. I'm creating the token, and by the time you're watching this demo, the token is already expired. I'm creating a generic Kubernetes secret using that token. So now that I have the token, let's see, YAML, which would have the definition for an event for PostgreSQL resource. So the usual API version and kind shows the event.io v1 alpha 1, the kind being PostgreSQL, which is a custom resource definition. And on line number 9, you can see the event-token, which we created. If you see line number 14, that's where the output will be for the database connection. The project name is dev-advocates, and that's on line number 17. So that's the logical concept of managing resources. I'm choosing Google Cloud, North America, Northeast 1 region. I'm choosing a hobbyist plan, but you can go for a higher plan using PostgreSQL version 4. And if everything looks okay, I'll do a kubectl apply and create the resource. So now that the resource is created, the reason I chose kubectl apply, it's declarative approach rather than kubectl create, which is the imperative approach. So I'll query to see if the resource was created successfully. So kubectl get of that CRD name should show me the status of that resource. I can see that the state is rebuilding, and this is the time where I go to event console and I can see that event for PostgreSQL resource is currently in rebuilding phase. This is setting up the VM right now. I fast forwarded the video for the sake of time, and the flashing blue was when the VM was setting up. The solid green indicates that the resource is ready for us to use. In order to validate that the resource was actually created, here's one more YAML. There can't be enough YAMLs. In this YAML, we are testing the connection. So if you see the last line, we are getting the environment from a secret called pg-connection, which we created in the previous step. So if we run this, the PostgreSQL version command would show us the version of PostgreSQL for the resource we created. And if we do kubectl logs command, it shows us the version of PostgreSQL. So that validates that we were able to create the resource using a purpose-built operator from within Kubernetes, but the database itself is totally outside of Kubernetes. Once we're done, we're deleting the pod, we're deleting the custom resource, and this resource should be gone from the console as well. All right, so now that we saw we can create a resource using an operator, and the database lives outside of Kubernetes, let's try to recap on the problems we discussed and some of the solutions or steps for those problems. So the first thing we talked about is storage, regardless of running storage on Kubernetes, is a hard problem to solve. But we can't just raise our hands saying that it's a hard problem, so we will not do anything about it. There are different factors to consider when we're choosing storage. On it by itself, nothing related to Kubernetes. We have the factors of accessibility, access mode, availability, replication factor, performance, and cost when we're choosing the storage. And then we talked about how do we choose database? And these are the 5 factors when we choose database. When we talk about the database deployment option on Kubernetes, now that we have the knowledge around the database, on the choice of database, we ask ourselves if the database is Kubernetes friendly, is there an operator to help, and is the workload Kubernetes friendly or not, and how much ops workload is acceptable for your team? Do you have the subject matter expertise, the time, and the resource to manage the database and your application at the same time? Or you'd like to focus on your application and you'd still like to use Kubernetes as a single pane of glass to manage your stateful workload, which is running outside of Kubernetes as a managed database. If you'd like to take a photo, this would be that slide. The QR code would point you to 3 resources. The first resource is the link to Ivan operator for Kubernetes. The second link is which automation tool to choose. You might have a question that I can use Ansible, I can use Kubernetes, I can use Terraform. There are all these different orchestration and automation tools. Which one do I choose? So there is a blog on that. And the final resource is I got the flowchart I have. That was an inspiration from a Google Cloud blog. It's a link directly to that Google Cloud blog that would point you how you can choose from whether running a database on Kubernetes or not, and step-by-step questions you can ask. If you have any questions, feel free to ask now. You can ask using the Hoover app. You can ask on Twitter, on LinkedIn, or you can shoot me an email. Those are my contact details at the bottom of the slides. Thank you so much for attending the talk, and I'll address the questions you asked using the app. So the first question is installing a database on VMs safe enough? Great question. So when we talk about installing database on virtual machines, so that relates to the first option we talked about. You have to consider the security of your database and the security of your virtual machine, because if either security gets compromised, your data would be compromised. So if you think about the security of the virtual machine, for a managed provider, they already take care of that security. The whole concept of where the database is running is abstracted away from you. But if you feel comfortable, if your engineering team is comfortable, you can install database on virtual machines. So you have to take care of the database security. You have to take care of the virtual machine security. The safe enough question is very subjective, is how secure and safe can you make it versus a team of experts who are doing this as their business. So the short answer is it depends, which typically no one likes to hear that, but actually you can do it if you have the engineering team to do that. The second question is something that I put up for the audience is, are you using Kubernetes to manage your database, and where and how you're hosting the database? I'd appreciate if you could answer to the question using the Hoover app, or let me know on Twitter or shoot me an email. Great question. The question is, are there any Kubernetes native databases? And what's the difference between them and the regular databases? So when we talk about Kubernetes native databases, so that's the slide I showed you from the CNCF landscape, specifically focusing on the database. And the difference is sharding or failover election. These are built into the DNAs of these database. The regular database, probably not. For a regular database, you'd have to use a purpose-built operator, which takes care of those things, but those are not built into the database per se. So that's one of the questions you ask. Actually, the very first question you ask is the database Kubernetes native or not? Awesome. Thanks so much to the host, to the organizing team, and to the attendees for joining the session. See you next time.